Hello my dear children of class 12 science. Today again I welcome all of you through this mode of teaching, and the mode which you are following is called YouTube mode. And in today's class we will start new unit, and this is for semester 2 examination, and the unit is unit number 7, dual nature of radiation and matter. So a very important unit, dual nature of radiation and matter. So basically in this unit there are 3 chapters. There are how many chapters? 3 chapters. But as for the reduced syllabus, we do only how many chapters? 2 chapters. The first 2 chapters. And one of the chapters that we are going to start in today's class is photoelectric effect. This is the chapter which comes under this unit that we learn from in today's class. And after this chapter we have matter wave, the short chapter that we do. So with that, these 2 chapters, your unit number 7, get completed. So to start today's class with this chapter, photoelectric effect. Okay, now this is one of the important phenomenon. Let me tell you, this is one of the important phenomenon which is actually give you the idea about the generation of what? Electricity. The generation of what? Electricity, even in the presence of light. The presence of what? Light. Because photo means light, electric effect means the generation of electricity. But when we talk about the generation of electricity, means basically the emission of electrons. Emission of what? Electrons from the metal. Now this concept was put forwarded by a number of scientists, but at last the only scientist who gave the complete explanation of this particular phenomenon called photoelectric effect was Albert Einstein. And he was the person who got Nobel Prize by explaining this particular phenomenon, that is called photoelectric what? Effect. But this is the phenomenon that can also tell you about the nature of light. The light means the radiation. But the chapter, a unit that we are going to deal in today's class is dual nature of radiation and matter. Radiation means basically the light, and matter means the particle. Means radiation has dual nature, means 2 nature. At the same time, matter also has 2 nature. Now one of the nature of radiation of light is actually a wave nature. So in wave optics you learn about that light travel in the form of wave. So that light has what nature? Wave nature. But children, the nature of light can also be a particle nature. Also what nature? Particle nature. Light consists of small packets or bundle of packets of particles. These particles are called photons. And the concept of photon is completely based on, explained in detail about by the chapter called photoelectric what? Effect. That's why photoelectric effect is one of the phenomenon, okay, that give you the idea that light also has what nature? Particle nature. Other than what nature? Wave nature. Okay, and this chapter is conceptually based on the particle nature of light. Now to start with this chapter, let me just tell you one example. Suppose you have a metal surface. Suppose you have a what? Metal surface. When you heat the metal surface, when you supply heat to the metal surface, suppose you are heating the metal surface, okay, so after some times what happens, once the metal surface acquires certain amount of heat, okay, energy supplied to the metal surface, then there is an emission of electron takes place. There is a what? Emission of what? Electrons takes place from the surface of metal. And the phenomenon of emission of electrons from the metal surface, when the heat energy is imparted to it, is basically called as thermic emission. This is called what emission? Thermionic emission. The thermionic emission is nothing but the emission of electrons from the metal surface when heat energy is imparted to it. But children, remember this, electron emission from the metal surface can also take place when you put some amount of light energy to the metal surface. That means there is an emission of electrons can also take place in the presence of light. And that phenomenon in which there is an emission of electron takes place from the metal surface under the effect of light is basically known as photoelectric effect. So the main objective of photoelectric effect is to emit the what? Electrons from the metal surface or from the metal plate in the presence of what? Light. So we can define photoelectric effect as the phenomenon of emission of electrons from metals under the effect of what? Light is called photoelectric effect. But children, remember this part, it doesn't mean that once you supply light supply light to the metal surface, then immediately there is an emission of electron takes place. It does not take place. Means photoelectric effect cannot be defined in all the presence of light. The light of all intensity, light of photoelectric effect cannot be observed with light of all intensity and all frequency. Okay, so there are certain conditions for the phenomenon like photoelectric effect to be defined. But when there is an emission of electron takes place, then this electron which is emitted by the photoelectric effect are basically called as photoelectrons. They are called what electrons? Photoelectrons. So electrons emitted are called what we called photoelectrons. Photoelectrons. So when electrons emitted from the metals, these emitted electrons are called photoelectrons, and the current produces, when there is a flow of current takes place because of the flow of electrons, and the current produced is basically called as what? Photoelectric current. And this is basically called as photoelectric current. That means we can generate current in the presence of light also, and that concept is known as photoelectric effect. And due to this phenomenon, there is a device like photovoltaic cell has been developed. Okay, photovoltaic cell is one of the devices which works on the photoelectric effect. But the concept of photoelectric effect was put forwarded first by one of the scientists, okay, whose name was Hertz. The full name is called Heinrich Hertz. So Heinrich Hertz is the name of the scientist in the year 1887, who put forwarded and first observed the phenomenon of photoelectric effect by doing a simple experiment. And children, as I said already, that photoelectric effect cannot be observed in all the conditions. So especially to observe photoelectric effect, okay, the light of short wavelength or high frequency is more effective than the light of long wavelength or low frequency. Means if there is a light of short wavelength or high frequency that produces photoelectric effect, then more effective than the light of long wavelength and low frequency. Okay, so this is one of the important points that you need to keep in mind. But as I said that the idea of photoelectric effect was first observed in the year 1887 by Heinrich Hertz, but his observation was remained unexplained because at that time the electron had not discovered. Okay, that's why the phenomenon of photoelectric effect was remained unexplained. But in the year 1800, I'm writing the year 1898, J.J. Thomson, who discovered electrons, who discovered electron? J.J. Thomson, okay, who discovered electron, okay, and he also performed the experiment of this photoelectric effect. So when he performed the experiment, okay, it observed that when light falls on a metal surface, there are some electrons emitted from the surface. So according to J.J. Thomson, it said that the particles which come out from the metal surface is nothing but the negative charge particles which are called electrons. And this electron emission from the metal surface actually makes the current to flow in the circuit. And this observation was even done by the scientist called J.J. Thomson. But his observation was just only the observation which remains, because after 2 years, so I'm telling you, after 2 years, that means in the year 1900, two more scientists whose name was Lennart and Halva, who even observed the same phenomenon experimentally, okay, and even it was verified that the emission of electrons which takes place from the surface when there is some amount of light or light of certain frequency is imparted to the metal surface. And this observation was made with the help of simple experiment. With the help of what experiment? Simple experiment. So the observation of photoelectric effect was even put forwarded in the year 1900 by the two scientists, Halva and Lennart. Okay. So according to them, the emission of electrons means the electron which was already discovered by J.J. Thomson and performed the experiment in the 1898 was further proceeded by these two scientists. And from there it was measured the current flowing in the circuit, and this current is called photoelectric current, and the electron which eject from the metal surface in the presence of light were considered as what? Photoelectrons. And these electrons are the electrons which are emitted from one metal plate to another metal plate. But for their observation, they took a tube, and this tube is called evacuated glass tube. So the experimental observation made by the two scientists, to observe photoelectric effect will be explained in the next YouTube video. That means we'll continue next YouTube video. But in this particular video, we just did the introduction of this chapter that is called photoelectric effect.